Mantling, or climbing up a ledge using motion warping, is a pretty simple way to have animations match the movement of your character. All it takes is a working animation and a few traces, and we can get very reliable results. If you don't already have an animation, I provide one linked in the description, or if you want to jump to the blueprint portion, skip it ahead to the time noted on the screen. Otherwise, I'm going to quickly cover root motion.
And many people get animations from Mixamo since it's a free motion library. And just because we have animations that appear to be moving, it does not necessarily mean that they are correctly keyed for root motion. Take this hang to crouch animation that I'm going to be using for this tutorial. The issues that you see with it come when we import it directly to Unreal Engine. You can see if we play the animation, our character is climbing outside of the capsule component rather than having the capsule move with the animation. If we were to open up the animation in the control rig, or better yet Blender, you'll see what the issue is. That bottom cone is the root, and all of our motion is not keyed to the root. All the motion in this animation is keyed to the pelvis, save for a few movements moving our character forward. In a way of fixing this, we can highlight all the movement keys for X, Y, and Z location for the pelvis, and then delete them. This will make it so then the animation is now an in-place animation, and then when we move the root, as the root is going to be tied to our character's animation now, the animation will move with it. And with those alterations, our character is able to mantle without moving outside of the confines of the capsule component. In your project, we can open up the content drawer and open up a third-person character. And at the very bottom here, we're going to be putting in all our logic. So to get our mantle, we want to use motion warping, but we need to be able to get ourselves to a specific point for that to work. I'm going to create a keyboard press. We could change it to E for now. And we're going to start off by getting a line trace by channel. And the idea is that we want to have a trace going from in front of our character, a little bit higher up, and going straight down. So then when it impacts, that's the point that our character is going to move to. So we'll get the actor's location. We'll get an add. We'll say add 150 to the Z value. And then we're going to add the actor's forward vector. We're going to multiply the forward vector by an integer so we can convert the bottom pin. And we'll say 120. Connect this to our add node, and that's going to be our start. Then we can just bring this back down to our actor location. That's going to be our end. So say we're standing here, we'll be able to move over to that point. If we do register a hit, put a branch, we're going to break the out hit. Because we might clip against an edge, we're going to set the actor's enable collision to false. Just leave that unchecked. And we're going to set the movement mode, so we can drag in our character movement. Get set movement mode to flying. And here's where we get to our motion warping. We can go to Edit and Plugins. You type in motion warping and select it. And it will require you to restart. After your project comes back up, you can open up your third-person character again. Add under components. You'll type in motion warping and add in the component. Then when we drag it in, we'll have options for a new node called add or update warp target. And we could choose any one of these, but we're just going to use the first one. And add off of warp target, we're going to type in make and get motion warping target. Now these targets work in conjunction with a montage. So in our anims, we have our brace to hang. We can right click, create anim montage. Then we'll get play montage. Our in-skeletal mesh component is going to be our mesh. And I only have one montage, so it is the one that we're going to use. Now, if we don't set anything here, it won't matter because we don't have anything set in our montage. With our montage, we want to climb our character up. And then after it gets to about right here, we want to move the character forward. With our notifies, I'm going to add a few more tracks. In any of these notify sections, when you right click and go to add notify state, you'll have this motion warping.
When the montage hits the motion warping notify, it works the same way as if we used a v-interrupted constant with the time of however long the notify is.
Which for this animation will say at the very start up until the 26th frame. Then we're going to add another notify state for motion warping, and we can overlap this for when we want our character to go forward, or add our warp target. So right when we get a foot on to our ledge, it kind of goes forward. And we can also add notify states as normal, such as if we wanted to have our character convert back to the walking state, if collision be set back to true before we get to the very end of the animation playing, we can set a montage notify. And just call it end. And then that's what we'll use to set everything back to normal before our animation finishes. In conjunction with the motion warping target, we have to give a name. And that target is going to be set inside the motion warping notify. Select the root motion modifier, the warp target name. We'll just call this up. And on this other one, I'm going to name as over. And in both of these, because we have a vertical animation, we want to make sure that ignore z-axis is unchecked for both of these. And everything else we can leave the same. In the core animation, if you open it up, we just want to make sure that root motion is checked. Otherwise, our animation playing is not going to work. Now for these two, this one is going to be up and this one is going to be over. And it doesn't matter which way we call this, as long as we have the targets set before we play the montage. We just want to make sure that our names are correctly spelled and also matching the same case sensitivity. For our up check, we're going to get our character's location. And we're going to add twice the size of our capsule height to this, so we can convert this into a float. Drag in our capsule component, then get scaled capsule half height. multiply it by 2. We get the full height of our capsule. And we do need to set the rotation as well. Since we're just going to be going straight for this animation, we're going to get the actor's rotation. Set that to be where we end up at. We're going to do the same for the second. The location for our over is going to be where our impact point was. So we can drag off of impact point. Connected there. And because we specified an end notify, you can drag off the notify name, get the switch on name node, disconnect it from the execute pin, and on notify begin. You can uncheck has default pin and just add end as our option. We'll copy our set actor enable collision in the set movement mode. Check new actor collision, and we will change this to walking. Now, if we go over to our cheer and press E, character kind of does a weird thing, and that is because we might need to go into the animation graph and remove the control rig. Appears to be skewing, so if we go back and check our work here, over as the impact point, up as in the actor's location, plus change this pin by splitting it and only having this be the Z value. Now if we go up to wall and press E, while we play the animation. It's a little bit slow, so if we quicken that a bit, say at 1.4, press E, it's a bit better, not by much. That is because we're staying in the animation a bit too long. So if we go back to our montage and we extend the blend in and blend out, we'll have our blend out time reduced from 0.25 seconds want to move over a little bit more and maybe end it a little bit quicker. And that is the very basics of motion warping. Now here I have the ledge grab level. We went through the ledge grab tutorial. From our mantle position, if we press space, we were able to jump. But now we can mantle directly from this position by doing what we did. Character, able to run up the wall, grab the wall, and mantle on top of it. Now, as far as bare necessities go, it's pretty much all we need, but there's a few other things that we can do to make this a bit more verbose. If we wanted to check to see if our character can actually move into the space that our motion warping will bring them in, we need to do another check. For our first check and our out hit, we want to make sure that our character is able to move to the space. If we go into a wall, for example, and we try to mantle, our character is able to do so. But we don't want to be able to do that. The reason why is because we're only checking to see if it has an impact point. But we want to make sure that our initial overlap is being checked. So that way if a trace starts inside of a wall, we don't want to go and proceed. So if we are not overlapping with something initially, and our trace returned true, then we go to our branch. Now we are no longer able to mantle while we are against a wall, and instead we can mantle if we have enough room. And you could do another trace starting from this impact point and going upwards for the value of our character's scaled capsule half height times 2, because that's going to be essentially the length of your character unless you have some mesh that exceeds the boundaries of the capsule. And because it is the scaled capsule half height, it should work with whatever capsule you want. I will get a line trace by channel and just copy it over. And for this, we want to make sure that we miss. So off of the false pin, we'll continue onwards. Our start is going to be the impact point. And our end location is going to be the impact point plus an add node. Split the Z value. Get our actor's scaled half height. Connect to the end. And it appears that the impact point is getting caught in the mesh, so we're just going to invert this. So we could switch this to be the start, and then it can go straight down to the impact point, so then it won't impact. If we started at the impact point, then it will clip with the ledge, apparently. That will match the height, but we also may need the width. If we didn't want to do just a line trace and check for that, we can get a capsule trace. Move our pins to same points. Now to get the capsule trace by channel working, we need to first of all switch these pins, because when we add the radius, we're going to be making the start wider than just the line trace. And we're going to need to add a little bit to our impact point. Again, add. And we want to take the capsule component and get our scaled capsule radius. And we'll split the structured pin for the add. We can attach that to Z. And we can connect this to the radius. Now, annoyingly enough, this is still going to overlap with this, so we need to add a pin. And we can just simply add 1 to our Z value of the added pin. Connect that to the start. There we go. So that'll get us into our spot. Now we still have an issue that if we wanted to spam our mantle, our line trace is going to keep going off, and that could mess with our traces. So at the start of our chain here, after we press our input, we're going to get a branch. And we're going to promote this condition to a variable, and we're going to call it can_mantle. Compile it and make sure that it's checked to true. If it is true, we immediately set it to false. And then we can copy it and all the way at the end of our chain. If you want to place it at the end notify, so then when you could mantle repeatedly over one object to another, you can, or you can wait until the animation is fully complete, and then we'll set it to be true. Now we're only going to do this once, rather than having our character stutter over and over again. We also have this by design to work with the ledge grab, because after the ledge grab animation from the previous tutorial is set, our character's capsule component is flush with the height of our ledge. But if you wanted to use this animation in, say, hopping over a barrier or a smaller wall, it doesn't do us much good to have us go up the size of the capsule if our ledge that we're trying to mantle on top of is not as tall. Show you what I mean, off of our previous mantle, it works well for that wall that is at least as high as our character's capsule component is, but on a smaller wall, our character clears a considerable amount of distance before we start going down. So we go over to our actor's location, and instead what we're going to do, we can change our math here and just make some room. We need to get the difference between the z value of the impact point and the z value of our actor's location. So off of our impact point, we can break the vector. And we can also do the same thing for our actor's location. We'll remove our capsule scaled half height here, and we will subtract and connect that to our z value. Our character gives a bit more of a uniform climb. Okay, and then we can give it a manual offset if we want to. Say like 35. And that'll get us more uniform movement across different sizes of ledges. And you can also get this z value and save it as a variable. And then you can do a check. So then if you have multiple mantle animations of a certain distance from the character's location to the mantle point, you can play those based on that. Thank you to Winterberry Shark and Thatcher Moss for putting my non-existent kids through college at this point, and thanks to everyone else who's contributed to growing the channel and the budding community on Discord. If you liked the video, let me know by liking the video, and subscribe to let me know that you want to see more Unreal Engine tutorials in the future. And if you want to drag and drop what I've done here or any other tutorials to your own project, you can get the blueprint and the components on the Patreon. So that's all I've got for now. Hope you have a great day, and I hope you've been inspired.